Good morning, geometry students, and welcome to lesson 7.5, proportions and similar triangles. As you can tell, we are cranking through our material. We are going to be finished up with chapter 7 this week, and this actually may be our last lesson, and then we will be reviewing. We have one more lesson that we'll do in class tomorrow. Then we will be reviewing and you will be taking a test on this material. So I would encourage you, if you have not already updated your flashcards, please do so to include this chapter's theorems and definitions, just so that you have those for the test. Remember, you can use them for the test. So please join me on page 386 in your book. I'll actually be doing a little bit more of showing you how to work out the various checkpoint problems. Some of the math gets a little tricky at this point, but there are some good examples, and so use those. I will also be doing a little quiz on Wednesday with some of these similar. I've got some extra examples in the book that I'm going to use for a quiz. But let's get started. Now there is a little orangey yellow box there. You're welcome to do any of these little extra things, and I will, if you do them, and they come up every so often, if you do them, you can hold on to them, but then attach them to your test. So if you want to attach it to your chapter 7 test, do the activity that they ask you to do, attach it, and then I will give you extra credit points on your test. So feel free to do that. All right, we're going to get started by looking at the big word that is on page 386, proportionality. And if you look at the two line segments below that, GH with point P in the middle and JK with point Q in the middle, we are going to try to understand what proportionality means. So we're going to look at point P. So they tell us to look at point P, which is right there. And it says, suppose that a point P lies on GH and a point Q lies on JK. So this is right in your book, so if you can either look at the book or the screen. Then we want to try to figure out if these are proportional, just like we were doing with triangle sides. And so we're going to set up a ratio GP over PH equals JQ over QK. And then we would plug the numbers in to make the determination about whether it is proportional. And so the little geo activity above that kind of leads to thinking through that. So if it were to be proportional, this one would come out to 3 over 6 would be 1/2 and 4 over 8 would be 1/2. So they would be divided proportionally. P and Q are divided proportionally on these lines. All right, so let's take a look at theorem 7.4. And I have just photographed these right out of your book. And I would suggest if, your flashcards, you could take a picture of them, put them on a flashcard, or write it out. So we want to look at the wording for this. If a line parallel to one side of the triangle intersects the other two sides, then it divides the two sides proportionally. So here is one side, Q and S. So if a line is parallel to one side, so QS is that one side, TU, and it is a symbol here that they are parallel. Then, so remember, our theorems are often if-then statements. Then it divides the two sides proportionally. So that means QR and RS are divided proportionally. And here they've written it out for us. Triangle QRS, if TU is perpendicular, is parallel to QS, then that means that RT over TQ is going to be proportional to RU over US. They're not saying that the two sides measurements are equal, they are saying they're proportional. Just like back here, these two are not equal. This one's 9 total. This one's 12 total. They're not equal. They are proportional. Okay, so let's go to example number 1. And this wants you to find the value of x. So you are now in a time in math where you've got to very carefully read the directions. Sometimes they'll ask you for the value of x. Sometimes they'll ask you for a total perimeter. Sometimes they'll ask you for a total side measurement. So you just need to be careful of what they're asking for. Now, we have some given information. Always look for that given information. It's right up here in the triangle. My segment DE is is parallel to BA. So now I can go back to this theorem and I know that my sides are going to be proportional. So I now know that I can set up this ratio math problem that I've got going here. And I have CD over DB. E is going to be similar in proportion to CE over EA. So then I put those letters. Now I replace it with my numbers. So I'm going to have 4. Here's your 4. Here's your 8. 4 over 8. And then I'm going to have x over 12. And then I do my cross multiplication. So I have 4 times 12 is 48. 8 times x is 8x. And then I need to divide by the 8 to get rid of, so x is all by itself. Divide by the 8 here, and I can find out the value of x, or the value of this line segment. Okay, so not terribly difficult. Let's take another look at a different one. And this one's going to be a little bit more difficult. It's going to require that you put on your thinking cap a little bit more, but we begin with the very same information. We are given information from the get-go. It's not written out for us, it's written in symbols. QT is parallel to RS. Make sure that you've got that information there before you begin to set up all your proportions. So because of that, then I know that this line over here, PR, is proportional to PS. But I'm missing some information here. I'm missing what this piece and Y are. I know that the whole thing is 20, but I don't know what the individual pieces are. So I set up my symbols first. PQ over QR equals PT over TS. Then I go back and I put my numbers in. So I'm going to put 3 over 9. There's your 3, there's your 9. Equals Y, because that's the one that corresponds there. Over, but I don't have a measurement for this one, and I don't know what Y is. So what I have to do is 20 minus Y will tell me that value. So 20 is the total, minus this little segment is going to give me ST. Okay, so that's what I put down there, just 20 minus Y. It's kind of like that substitution thing going on, where we're substituting something in. And now I cross multiply blues, reds. So I'm going to have something in parentheses, 3 times 20 minus Y equals 9 times Y. And then I have to do my whole distributive, remember that? And I'm going to have 60 minus 3Y. So 3 times 20 is 60. 3 times negative Y is negative 3Y equals 9 times Y, 9Y. Then I go on to resolve my my equation here. I'm going to add 3y to both sides, so I'll end up with 60 equals 12y. Divide by 12 and 12, and I end up with 5 equals y. Now I could go back in and put 5 in for y, and then I could also put the 15 in ST. So we are going to do an example of that one in just a second. So if you're not sure about that, we will be doing that. So let's take a look at our next theorem. and that is converse of the triangle proportionality theorem. So remember, often we'll throw out a theorem and then we'll do the kind of the backwards of it. So here's the words. If a line divides two sides of a triangle proportionally, then it's parallel to the third side. So we don't see the parallel symbols here. But if we are able to find out that RQ and RS are proportional, then we know we've got parallel lines. Okay, so this is just the backwards of it. So let's take a look at an example here. It says, given the diagram, determine whether MN, this guy right here, is parallel to GH. Now, if I look at that, I'm thinking it looks a little skewed, so I'm not completely sure if it's going to be parallel. The only way I'm going to be able to figure that out, though, is to do these proportions. So I'm going to do LM over MG, so that's my first set of symbols, then equals LN over NH. That's my second set of symbols. Now I go through and put my numbers in. So for LM, I'm going to put 56. For MG, I'm going to put 21. And I come out to have 8 over 3. Then I come over here, I'm going to put 48 over 16. Here's your 48, here's your 16. And I have that coming to equal 3 over 1. Well, those are not equal, so I can now determine that MN and GH are not parallel. Okay, let's go on to do a couple of these. And I want to take a look at this one. And this one's pretty easy. And so it wants you to find the value of the variable. And so we know we've got a couple things going on here. We know that this is parallel. So then we know that these are proportional. So I am going to set up, and I'm going to do this with you. So I'm going to... All right, so to explain this to you, let's take a look at the next slide. And I'm going to write my proportions. So I've written 5 over 10 equals 4 over x. Then I can reduce the 5 over 10 to 1/2 equals 4 over x. And then I would do the cross multiplying. So the 2 would multiply against the 4, which would be 8, and the 1 against the x. And you are left with 8 equals x, or x equals 8. So that one's pretty easy. Let's take a look at the next one. Okay. And, oops, I did this one twice. Or no, wait a minute. Is this the same one? It is the same one. I don't know why I did this one twice. So let's go on to the next one. But we did get, I did it a little differently there. I didn't reduce this one. So you can do it where you keep the 5 over 10 and the 4 over x. You get 40 equals 5x, x equals 8. You can do it either way and you'll get the same answer. But let's go to the next one. I don't need to repeat the first one. All right, so this one is one of those that has the little tricky math in it. I do learn here that I've got my 2 parallel lines. So I've been given that information. I know I've got the segment that divides these proportionally. And so now I'm going to proceed, and I'm going to be able to put, let's get there. I put my 15 over 6. Here we go, 15 over 6. And then y is the little part that coincides with 15. So I'm going to put y over, and then here's my total. 14 minus y will give me this little piece right here. So I put 14 minus y. Then these dotted lines represent my cross multiplying. I should have done different color markers or something, but I didn't. So 6 times y is 6y equals 15 times 14 minus y. So then I'm going to do my distributive, remember, multiply by each. I'm going to end up with 210 minus 15y. I'm going to add 15y to each side, and I'm going to be left with 21y equals 210, or y equals 10. So this little part right here is 10. or no, excuse me, this is 10 right here. That doesn't make sense. This is 10, this is going to be 4. Sorry about that. All right, let's look at the next checkpoint. And these give a little bit different instructions, so make sure you take a look at that. And I want you to pause, and I want you to try this one. It says, given the diagram, determine whether QR is parallel to ST. So I want you to take a minute, hit pause, and I want you to determine whether RQ, this guy right here, is parallel to ST or TS. They don't give us any symbols, so take a second and try it and then come back. Okay, if you're back, let's take a look at this one. So with this one, I am going to set it up like this. I'm going to have my 15 over 21 equals, in the smaller portion, 17 over 23. And then I'm going to go through and do any reducing that I can. Let me see, 3 goes into 15 5 times, 3 goes into 21 7. But this guy doesn't reduce at all, and these are not proportional. So then we cannot say that RQ is parallel to TS. All right, now try the next one. Number 4 on page 388. Hopefully you've been following along and know exactly where we are. I want you to hit pause and try that one for a second. And then when we come back, we'll determine whether QR right here is parallel to ST right there. And if you're back, it's because you're ready for the answer, right? So here we go. So I am going to set up my proportions. I'm going to put 4 over 8. And it doesn't really matter how you set them up. You can put the big number over, as long as you do the same on both. So 4 over 8, is it equal to 6 over 12? So I put all of that here. And then I determine, after I do all the reducing, that yes, they are both 1/2. And so yes, these lines are parallel. Remember what they're asking for. They're not asking for this. They're asking if they're parallel. You have to put yes or no. All right, let's take a look at, this is our last page, page 389, the mid-segment theorem. The mid-segment of a triangle, if you look above there, is a segment that connects the midpoints of 2 sides of a triangle. This isn't necessarily a proportional thing. This is connecting the midpoints, making both sides of that equal. So the following theorem about mid-segments is a special case of the triangle proportionality theorem. The segment connecting the midpoints of 2 sides, this guy right here, DE, of a triangle is parallel to the 3rd side and is half as long. So DE is going to be half as long as AB. It's parallel. And it also makes these equal. So in the past, we've been looking at proportions. You know, you might have 4 over 8 and 6 over 12. They're proportional, but 4 does not equal 8. In this case, these are equal, okay? Let's take a look at how this works. So it says find the length of QS. They want to know this length here. They've given us very important information. We know that this is equal, or that RQ is equal to QP, and RS is equal to ST. So then we know that this is the midpoint. We also know that it makes it half of PT, the one that it's parallel to. So we can set up a little formula here. QS equals 1/2 of PT, this guy right here, or 1/2 of 10, which is 5. That means that QS is 5. So let's try some of these. So we look at this triangle and we are able to determine that it is this is definitely the midpoint, because this is equal to this is equal to this. That means that P is going to be half of 16, making it 8. The next one in your checkpoints, I want you to try, And it says find the value of the variable. In a minute we're going to find a perimeter, but I want you to find the value of the variable, which is Q. So you need to think about that. Just come up with a number in your head. And let me see if I wrote the answer down or if I'm just going to tell you. Nope, I'm just going to tell you. So we find out that we have a midpoint because 8 is equal to 8. 11 is equal to 11. So that means this line is parallel to Q, and also this little line in here is half the value of this. I hope you didn't go backwards and think this was 7. Instead, this one's longer. It needs to be 28. So you've got to think interchangeably on those. All right, let's take a look at one more. And this one is on page 389 at the very bottom. It says use the mid-segment theorem to find the perimeter of ABC. So really what's missing is this piece down here. We know that we have 3 plus 3. I've pointed that out over here. 3 plus 3 and 4 plus 4. But we need to know what this is. Now, we know this is parallel to this because of these. So that means we have to think about, okay, BC is going to be double this number, which is going to make it 10. So you're going to add 3 plus 3, 3 plus 3 plus 4 plus 4 plus 10, and you're going to come up with a total of 24. Okay, lots of information in this chapter. Hopefully you've learned it well. All of the examples are in the book. I will post the PowerPoints all by itself without my voice behind it on the documents section. Of course, this was on the media section, so if you got caught or stuck on any of those, you can go back and take a look at any of the checkpoints that you had problems with. So I will plan to see you tomorrow in class, and have a good rest of your day.